Hello guys, this is our anaerobic reactor which is from the GUNT company, and this one is now under maintenance. So you can see here the code is 6CE702, and this is our layout diagram. This is our main control unit, and we all know that anaerobic reactor, or you can say the anaerobic water treatment, is basically used to eliminate undissolved and dissolved organic substances from the water. And the anaerobic microorganism basically utilizes the organic substances as a source of nutrition in order to degrade them. So it results in the biogas as the product, which mainly consists of methane, which is 60%, and carbon dioxide, which is 35%. Anaerobic processes are basically suitable for wastewater, which has very high concentration of organic substances. That is basically from the food and paper industries, as an example. Now, the choice of the procedure basically is dependent on the or reliant on the properties of the substance that are removed from the water. Now, the basic, the can say the general information for these instrument is we should know what is anaerobic water treatment, and we should know the impact of the temperature and pH value on the anaerobic degradation, and the functional principle of the upper anaerobic sludge blanket reactor, which is UASB reactor, and the comparison of different operating mode, that is first stage, second stage, and the optimization of operating conditions. Now the basic can say is the how to put the water, or you can say water connection, and how to drain the water in the floor, and the means of biogas resulting from the anaerobic degradation that can escape, and for the laboratory analysis of wastewater or samples. This is my typical layout, or you can say the process schematic of the device. This one is the B1 is the raw water tank, which is now among these is one of them is the B1, which is the raw water tank, which is to be treated, and the B2 is this one, which is the treated water tank. Now B3 here, if you see B3, this is our B3. This B3 is basically the third tank reactor, and this is my B4. B4 is my secondary clarifier, and B5 is my B5, in which I'm going to, this is my acidic tank, and B6 is my caustic tank, and B7, which is here, this is my USB reactor, and B8 is my, which is here, and which is the foam reactor, and H1 and H3 are my heaters. This is H3 here, and H1 is this one, and P1 is my raw water pump, which is here. P2 is the return sludge pump, and P3 basically here is the metering pump, which is probably used to transfer the, you can say, the chemicals. P3 P4 are basically the metering pumps, or P3 is for acid pumping, and P4 is for caustic, and P5 is the recirculation pump. This is my P5, which is at the back. This is the P5. P6 here is the feed pump, and P7 is the, which is here, is the treated water pump, and then R1 and R2 here is the stirring, you can say, for stirring the machines, and L1 and LHZ, these are different levels. This is LHZ here, you can see here LHZ. These are different kind of level switches, a different kind of, which is Q102, Q103, which is used for measuring the, this one is a probe which is used for measuring the pH, Q102, and then we have the Q1. So these are Q102, which is basically used to measure the pH. They are different kind of probes. Now T1O1, T1O4, TIC1 and TIC2 are basically temperature stir tank reactor. Then we have a temperature USB reactor. Then we have temperature controller tank reactor. Then we have temperature controller, which is the UASB reactor here. Basically we have this is my the supply unit, and this is my trainer unit, the whole component. The one here, if you see here, is the raw water pump here. This is basically the raw water pump, which has a three-way valve. And then this is the corner right one is the treated water tank, and this is my raw water tank. Then they have a drain valve, which is to be connected with the main equipment. And this one is the first one is my foam reactor, which I already told you. First one is the foam reactor. The second one is my USB reactor. Then we have a secondary clarifier. And then we have the switch cabinet, and this is the one we told about the metering pumps and the heaters. For the first one, we basically provide the feed, and then which is to be located in the base of the reactor, and the outlet which is located on the right side of the reactor. Now the stirring machine R16 is basically the first part, which is basically used to mix the content of the reactor. The heater H1 is built into the base, which is at the base 1, and there is a temperature sensor which is called T101, which is located roughly in the center of the reactor. Then we have a temperature sensors and heaters part of a control loop. We also have a pH sensor which is integrated into a holder. Then the reactor is also fitted with the level switch, which is called LHZ1. And then we have a gas generation operation, which is channeled away via a separate line, which you can see at the back. Second part is my secondary clarifier, and where the biomass is discharged from the stirred reactor settles in the clarifier. There is an inlet into the secondary clarifier, which is located on the left hand side. You can see left hand side there is an inlet. Sedimented sludge collects into the funnel here, and clarified water continuously leaves the secondary clarifier via the outlet. This outlet, it will be leaving, and the return sludge pump feeds the sedimented sludge back into the stir tank reactor. This may lead to a channel forming in the sludge bed, such that the return sludge pump predominantly pumps the clarified water located above this channel. Now the secondary clarifier is also fitted with the level switch, unlike the first reactor, which was the stir tank reactor. And then the interior of the secondary clarifier can be made accessible by opening during the commissioning, by opening the inspection panel for cleaning purposes. And the gas generation during the operation is channeled away, unlike the first reactor, by a separate pipeline. The third one is my USB reactor, which is located into the base of the reactor, base 2. The base 2 basically is this one, base 2, and the outlet is located in the upper section for separating the gas produced during the operation. The separation system also causes the biomass to remain in the reactor. The heater H2 is built into the base. The temperature sensor, and then we have the reactor also has again level switches, unlike the first and second reactor. There are 3 connections for the sensor on the side of the reactor. The connection can be individually for other sensors, and the gas generator is again channeled away from the foam to the foam separator. So the last one is my foam separator via a separate line. In order to prevent the pressure in the reactor becoming too large, we have a safety valve. This is my safety valve here at the top. And also we can clean during commissioning or some other kind of operation. We have the foam separator. So there can be severe formation of foam in the gas compartment. So gas is fed through a foam separator in order to separate the foam from the gas. Now the gas enters the foam separator from above along with the foam. The foam is retained in the tank. Meanwhile, the cleansed gas passes through the outlet 4 back of the foam separator, which is at the back. You can see at the back we have a separate line. To prevent the pressure in the foam separator becoming too large, so again we have a safety valve This is my safety valve, okay, which is called valve V3. And now we have the tank B5 and B6, which is the receiver tanks I told you earlier. I have three safety valves, which are the first, and then this is the second one, and then this is the third one. Other than safety valve, we have other safety valve also, which is V27, and this safety valve is located in the feed line to the USB reactor, and this safety valve V27 triggers at pressure more than 6 bars. Let us find out where is V27 here. Here is my V27, which is at the basement and which is near to my USB reactor. Here you can see this is my switch cabinet. Now if you see here, this is my stirring machine, and this is my return surge pump, and this is for the heater, this is metering pump, and P3 P4. Then this is my main, you can say, you can see the process variables. This is the heater, this is both are the for the H1 and H2. Then we have temperature controllers, monitor or water pump, then this is combustion pump, this is stirring machines, and this is feed pump, this is treated water pump. This is the levels basically. And connect this USB port through your computers or through your personal PCs or laptops. Generally there are three stages. So in the first stage you need to connect A and C, and then you need to connect C and D as mentioned in your equipment manual. Connector A and C are located on the supply unit, which is here, and then connector C and D are basically B and D are on the trainer unit. Connector B and D are close to the valve V4 and V14. Now we have to for making this operational, we have to connect the supply unit and trainer unit electronically. Here this is my supply unit, so which has to be connected from the supply unit. This is my connection for the supply unit. Stage 2, you have to remove the two pH sensors and their cover pack, and then you have to connect this with the reactors, which is a stir tank reactor and the mechanical clarifier. And then you will be and then we have to switch on our device, which is here, and then we have to calibrate our sensors using the buffered solutions, which we saw in our earlier videos. And then the stage 3 is you have to disconnect the cable of the pH sensors, screw the pH sensors, reconnect them, and then same thing we will be applying for the second, the other tubes or other probes. And then stage 4, which is the last stage basically, you have to open the valve V3 here, which is in the main supply unit. Close another valve which is V1 and V2, which is again on the supply unit. And then we have V6, V8, we have V11, V13, V16, V17, V20, V22. We have to locate them and then close. Then we have the adjust the three-way valve, which is V3, okay, on the supply unit, okay, and then adjust the three-way valve, which is V21, on such that the water flows from the USB reactor to the supply unit. Then we have to move the three-way valve, which is V4, V5, V7, V14, and V15 to the position which is shown here. Make sure they are on these positions. Now we have the stage 5. Okay, I told you earlier there are 4, but we have stage 5, and we have to completely fill the tank B1. Okay, tank B1 the tap water, and then tank B2 about a quarter full with tap water, that should be 1/4. And then we have to check the connections of the drain valves V1 and V2, which is not leaking, which is on the supply unit. Okay, and open the valve V2 to empty the treated water tank if there is a treated water tank there. Then close the valve again. Then we have to fill the stir tank reactor, which is B3, with the tap water. To do this, you can open the ceiling. You have to open the ceiling of the cap in the reactor. Once the level reaches the height of the outlet, then water will flow into the secondary clarifier. Then we can get these same levels, and make sure we don't fill the stir tank reactor completely. Then we have to open the inspection panel in the lid of the USB reactor, this one, okay. And then also we have to fill the USB reactor with tap water holding the hose, okay. Now we will also be completely fitting the metering devices which is at the bottom, and then we have to turn the following components: R1, which is the first one, then R2, then raw water pump, and return sludge pump, the circulation pump, and check the speeds. Also we have to make sure they are operating at the optimum conditions or the conditions given. Stirring machines also we have to back off and return sludge P2, and then we have to also check the level switches which are in the first tank, the second and third one, and then we have to turn the also we have to make sure about the pump P1 which stops automatically, so there is no more water into the stir tank reactor. Then turn pump 6 and wait until the second clarifier is so full, okay. Now also care about the levels in other tank reactors, okay. Now this is all about the theoretical discussion, okay, of the, and we also missed about the stage 7, where you have to, if you are installing the software on unsuitable computers, so you have to refer to the chapter 341 on the page 46, okay. And also we have to care about the, in the commissioning we have to turn off all components, okay, turn the device off, then disconnect the switch cabinet, disconnect the hydraulic and electrical connections between the supply unit and the trailer, which is the left and the right hand side, and drain all the tanks and pipes. It should not have water long, so that the probes and the other the things get corroded, and also remove the 2 pH sensors that are mounted in our device. So these are all things we have to take care, and the basic thing is we can analyze our the water which we are going to bring, the composition of the wastewater. Mainly we have to check the BOD, COD of them, and the pH, and the other parameters that we can find out the biomass concentration, okay, and the volumetric loading, the sludge loading, sludge age, and the return sludge ratio, okay. And there are other like we should be aware about the hydrolysis, the acidification, the 4 stages basically: the acetic acid formation, the methane formation, and the other influencing factors, like we must know about the psychrophilic range, mesophilic, thermophilic, okay, and the characteristic of the sludge that are going to be produced, and the characteristic of the biogas produced, the hydraulic detention time, and the temperature in the reactor, pH level, okay. These things we must know about it. So this is all about the theoretical part, okay. We will be uploading good videos related to its practical demonstration also. Don't forget to like and subscribe.